Alrighty, we're closing in on the end of the year here. This is section 11.8, Mixed Expressions and Complex Functions. So this is all about complicated fractions, basically. So converting between fractions and mixed numbers, and then combining fractions that have complicated numerators and denominators. First, what is a mixed expression? A mixed expression is going to be anything that has some fractions mixed in with some non-fractions. So polynomial with a non-fraction part, and rational expression will be the fraction part. Remember, you can remember that because rational has the word ratio inside of it. So ratio is a fraction, basically. So mixed expression has some fractions, some non-fractions. A complex fraction, on the other hand, is a fraction inside of a fraction. So for example, you have a fraction bar, and then in the numerator, you might have another fraction like a over b divided by c over d. Okay, so a fraction inside of another fraction, or division by a fraction. So this is something that you should have seen before in other math classes, just with numbers, but now we're going to be doing it with variables. Problem solving tips for this section. First is, when dividing by a fraction, you multiply by the reciprocal. That's something we just did in the previous section, but just to reiterate, if you have a division by a fraction, instead multiply by the reciprocal and show your work there. Second thing, when you're doing word problems, you want to make sure you show your units. So the units would be like meters per second, or kilometers, or number of times this happened, or whatever they are. So you've got the numerical value, but then you've also got the unit of measure. So make sure that you show your units in the numerator and the denominator so that they cancel out properly, so that you don't accidentally multiply when you should have divided, or divide when you should have multiplied. By showing these units and making sure that they cancel out properly, you'll really reduce your chances of making a mistake. Again, reiterating things that we've been doing all chapter, remember to factor and cancel. So you want to factor and cancel and reduce your terms down before you multiply and make them larger. So start off by factoring and canceling. And then very last thing is, when you're dealing with fractions, sometimes you have a whole number and you forget that it's actually a fraction with a denominator that's a 1. So anytime you're trying to combine fractions, you can just add a 1 in the denominator of something if it doesn't already have a fraction. Okay, some examples. Write each mixed expression as a rational expression. So we're taking something that's got a fraction here and a whole number here. To combine them together, you need to get a common denominator. Now, of course, the 6 really has just a 1 down here. So to get a common denominator between a 1 and an h, we're just going to make this h and h. Okay, so we have 6h plus 4, 6h plus 4 divided by h. There's our final answer. We've now combined it into a rational expression. Now, if you notice, you could butterfly this to spread it back out. So 6h over h plus, and then here 4 over h, if you butterfly it back out. And this reduces, right, to just the h's cancel. 6 plus 4 over h. So combining and then uncombining is really using the butterfly technique to go backwards. So you can check all your answers by doing that. Let's try number 3 as well. We need a common denominator, which is a c. So we have a c here, we add a c here, and we get 4bc over c plus b here. Okay, so numerator 4bc plus b, 4bc plus b divided by c. So all these are kind of the same. You just get a common denominator and then you combine them together. Now simplify each expression. These are a little more tricky. In the numerator, you want to convert this from a mixed number into a fraction. So remember, 2 times 2 plus 1, that's going to be 5 halves divided by, now here we got 4 times 4 is 16, 17, 18, 19 fourths. Okay, so that's going to be 5 halves. Instead of dividing, we change it to multiplication, and then we do the reciprocal. So here we go, 4 19ths equals. Now instead of blindly multiplying across the top and across the bottom, we can reduce here. We got 4 and a 2. That's going to reduce to just a 2 and a 1, you don't have to dollar 1. So 5 times 2 is 10 over 1 times 19 is 19. So 10 19ths. A lot easier than doing some crazy stuff that you would have had to do over here. Let's try one with variables. Here we got a squared over b cubed. Now instead of dividing by a fraction, we're going to multiply by the reciprocal. So we flip that upside down. You got the b over the a. Then you can reduce a squared over a is just a. B over b cubed gives you a remaining b squared in the numerator. And we'll do one last example for good measure here. So we got x squared y divided by c. That's our first piece. and then we're going to multiply by the reciprocal here. So c squared is in the bottom of the bottom, that goes to the top, and this part xy cubed is now in the denominator. Okay, let's simplify the c's first. C squared over c, this reduces to just a c. X squared over x reduces to just an x. And y over y cubed, the bottom wins by 2. So cx over y squared. So all these kind of problems you're just going to be combining and simplifying. Let's move on. A little bit harder ones, okay? Let's take a look at 15. So in the numerator we've got this complicated expression, and in the denominator we've got this complicated expression. So it looks at first glance insane. Maybe you look at that, you're like, wow, that is crazy. But remember, the model of this story is factor and cancel, and then multiply by the reciprocal. So let's just start with this top. Let's factor out a k. So we're going to get a k outside, leaving behind k plus 6, close parentheses. And now out of this denominator here, looks like we can factor that as well. Okay, so k squared is going to give me a k in the front. Two things that multiply to negative 5 and add up to 4 is going to be positive 5 and negative 1. Okay, now I'm going to multiply by the reciprocal of this stuff. So that right there goes to the denominator. So I've got my k minus 8 in the denominator. Okay, now this part right here I can factor, and I reciprocated it. So I've got my k in the front, k in the front, of course. And now two things that multiply to 8 and add up to negative 9 is going to be negative 8 and negative 1. Okay, so now I've factored each piece and I've reciprocated the part on the denominator, so I'm multiplying by the reciprocal. Now I can reduce and cancel everything that cancels out. So I've got here a k minus 1 and here a k minus 1. I've got here a k minus 8 and here a k minus 8. And so almost everything canceled. I'm left with k times k plus 6 in the numerator and k plus 5 in the denominator. Final answer. So it simplified quite a bit, right, by factoring and canceling. This one is going to do some crazy stuff and simplify a ton as well. W and W are going to cancel. W squared minus 16. That's going to reduce. Here, let's just do this one. Last one, here we go. W plus 4 over W multiplied by, now I want to reciprocate this, so the W goes in the top. W squared minus 16 is going to go in the bottom, but that's a difference of squares. That's going to be the W plus 4 and the W minus 4. So W's cancel, W plus 4's cancel. Final answer 1 over W minus 4. Right, so it's kind of cool. I like these problems because you can start with something that looks incredibly complicated, and most of it will simplify and cancel and leave you with just simple answers. Okay, so moral of the story here is factor and cancel, and then if you have division by a complicated fraction, multiply by the reciprocal. I guess one more thing is, how can you tell which piece is the numerator and which piece is the denominator if there's just 3 bars together? You should look and be able to see that one of them is longer than the others, and also one of them lines up with the middle of the problem. So right here, see this bar right here lines up with a 20, so that tells you this part is one fraction and this part is the other fraction. Now notice this one doesn't have a denominator, so remember that's just over 1. Likewise up here you've got this part in the top, this part in the bottom, and I already put the parentheses there. So if you're at all unsure, you're always welcome to ask, but in the textbook look at how they line up to the number. One of the bars should either be darker or longer, and it's good practice to put parentheses around the pieces in the top and the bottom so that it's clearly identified which fractions bars go with which pieces. Okay, that's it for this section. I'll see you in class.